30 minutes to do a quick introduction about driverless AI, which is the tool we were going to use today in the lab. And then, you know, after 10, from 10 to 12, you will have 2 hours to do some hands-on, you know, experiment by yourself using that tool. We will provide you a cloud environment. You just need to go to the website, log in, and then, you know, we provide you the license key you can play around with. You will get 2 hours of an instance running on Amazon EC2. So that's free for you to use. We have some very detailed instruction about, you know, what's the data set you can use, what's the experiment you can try. Other than that, if you have extra time, I really recommend you to use your own data. If you have some any own data, like, you know, public data or your, you know, private data, I mean, you can just import your data into driverless AI. Okay, so again, my name is Feng Bai, F-E-N-G-B-A-I, pronunciation like Feng. So I'm a data scientist and also analytics architect at H2O.ai. Today, I will going to introduce, you know, our company first, and then also I'll give you a brief introduction of driverless AI, and then we will do some hands-on experiment. We have one lab that will start one Amazon EC2 instance, and then you can run several different things there. We have detailed instruction there. After that, if you are interested, you can try your own data, either public data or the data on your laptop, or maybe somewhere on the cloud. You can try it yourself, and then we can discuss your project. We can discuss your experience, or you can ask us any questions about, you know, this product. So about H2O.ai, we are a company founded back to 2012 in Silicon Valley. So far, we already raised like $75 million. The big investors, they are including Wells Fargo, NVIDIA, all these kind of big companies. The interesting thing for me is the last round, C round, we sold in last year. So actually, most of the investors, they are our customers. So we said no to VCs because our customers, they are so confident. After they use our product, they are really confident on us. So they want to invest on us. That's why we will give the priority, you know, to them, not the VCs. The product line we have, and later on I will show you, what product we have. And based on Gartner's Magic Quadrant, machine learning and data science platform, we are the leaders and also visionaries in this area. You can check it on website. Just go to Gartner, search the Magic Quadrant. Okay. Oh, okay. I'm sorry. Let me just maybe fix the connection here. I won't touch anything. So anyway, for the team, so far we have more than 130 AI machine learning experts in the team. We are also expanding. Our plan is maybe reach to at least 200 people by the end of this year. Globally, we have offices in Mountain View, California, which is our headquarters. And also we have in London, Prague, Singapore, and India, we have our offices. Inside of US, we are going to open our new office in New York City very soon. Okay, this is our product line. So on the left-hand side, you can see we have, H2O.ai, that's an open source platform. Actually, the left-hand side, 1, 2, 3, 4, H2O.ai, sparkling water, H2O for GPU, and also Steam. Those are open source platforms. And then we have commercial license software, which is driverless AI on the right. Today, we are going to focus on driverless AI, which is an automatic machine learning tool. Customers. Oh. Okay, it's coming out. These are some logos. We have so many customers. I cannot put them in one slide, but these are just some big names in different categories. We don't focus on special vertical. This is just a machine learning AI platform, so you can run it in any special industry. In this slide, actually, I didn't separate the customer from our open source software or driverless AI, but they are mixed together. So partner ecosystem, we have hardware partners, we have cloud partners, and also we have strategic like Intel, NVIDIA, IBM, some big names here, but I'm a technical guy, so I will just quickly go through this slide, and then we will go to the lab talking about how Driverless AI works. Okay, Driverless AI. What is Driverless AI? Driverless AI is an automatic machine learning tool. I will highlight several features before we go to the details. So automatic feature engineering. For a data science project, from the beginning, you got your raw data. And then the first thing data scientists, they will do is they do all kinds of transformation, play with the data. For example, you have categorical variables. You have to convert them to numerical values. Or you look at your interaction terms. You look at your square, cube, or maybe some kind of other transformation, like based on date. Maybe you need to create day of week, day of month, and to try to catch this kind of time trend in your modeling. So you need to create new features and then test all these features in the later modeling process. That's a long journey. I mean, in my opinion, maybe 70 or 80% of the time for a data science project, you are spending on feature engineering. You need to generate new features and then test these features to see which feature will be used. But most of the time, maybe these features, they are useless. You have to just try it again to do new transformation to see which one works. So maybe use like 3 months to build a good model. I mean, people asking you, what's the magic? I mean, you said maybe 2.5 months I'm spending on the data. I mean, I do the transformation, try to figure out what's the best variables I can use in my model. That's the secret. So actually, inside of Driverless AI, we will do this automatically. We are the only vendor who is doing that. On the market, I don't know if there's any other vendor who will provide this feature. So after you give us the data, we will try all the combination. We will try interaction. We will try all kinds of target encoding, for your categorical variable, or we will try all kinds of, metadata features from a date column, or we will try all the combination. I mean, we will create clusters on your variable to see which cluster is more significant for the final modeling process. So all of these, they are automatically done inside of Driverless AI. That's the first highlight I want to mention. Second one is the automatic visualization. You will see this by yourself later. So after you give us the data, automatically we will generate some charts that the data scientists should pay attention to. We don't generate charts for every single variable. We check your data, and then we give you the charts that we think you need to pay attention to. Like, maybe we will give you a correlation graph that show you have so many variables with very high correlation. Maybe you need to pay attention to that. Maybe you have some data leakage based on your data. That's where you need to deal with. You think about your variables again. You find out some variables maybe you should not use for this modeling process, and then you drop them before you go to the modeling part. Machine learning interpretability is the third highlight I want to mention. Machine learning models, most of them, they are non-parametric models. They are tree-based on models or deep learning or, maybe support with SVM models, GBM models. Those are, not like linear models. Clearly, you can see the pattern, what's the impact of your variables, based on your coefficient in your linear model. So we give you a package inside of Driverless AI. We call it machine learning interpretability. In that package, you will get the latest or the most popular, people call it explainable AI methods, like Shapley values or variable importance. Yeah, that's the booklet. Yeah, we have some booklets here. You can grab after this meeting. And also surrogate models, which is another technique people will use to understand what's happening inside of this kind of black box machine learning models. Scoring pipeline, that's another very good feature. So after you build a model, generally in real world, you have to, data science team has to pass this model to another IT team to develop their scoring pipeline. Generally, that's Java or maybe Python or maybe C++, whatever the language you are using. Your IT team, they need to replicate whatever you are doing for your variable transformation and also model calculation. And then they put that package into your production environment. So that's the whole process. But for us, after you build your final model, we give you 2 independent packages. These are Python wheel file or Java jar file. You can deploy these files to anywhere you have Java or Python available. So they are ready to use. All the calculation will be done by these packages. After you import this package, you just call an API, call one single function to put your raw data in, and then in that function, we will do the calculation, we will do the transformation, we will do model building, we will give you the final predictions, along with the machine learning reason code. So 2 parts. Finally, I will mention automatic documentation. So after we build a model, how can you pass it to your coworkers? Explain to other people what's happening inside. We provide you a very detailed Word documentation along with other, text messages. So the Word documentation is the main thing. In there, you will see all the, models we built, all the transformations we did, why we choose the final model. So all the technical details. You can see that by yourself later in the lab. Let's quickly go through, other stuff. I just want to highlight that. 5 minutes. I want to finish this presentation in 5 minutes, and then I will give you 2 whole hours to, do your lab. So far, Driverless AI can only handle supervised learning. So we handle regression or classification. Unsupervised learning methods like, clustering or maybe like PCA or SVD, these kind of things, they are coming, they are on the way, but right now we are focusing on supervised learning. Feature engineering, I already emphasized it several times. Let me just show you a graph here. So this is the benchmark I want to show people generally. We use Driverless AI to do, finish several Kaggle computations, on the Kaggle website. So this is the result. You can see here, without any feature engineering, you will get the, the yellow line, which is the GBM baseline. Just use the feature they provided. Maybe you manually created several things, but without heavy feature engineering effort. That's the baseline model, yellow line. And then, the pink line is the Kaggle Grandmaster Best. That's the best result coming out from the top data scientists around the whole world. And then, the black line is the result directly coming out from Driverless AI. So you just put the data there, run the computation, build your experiment, and then we give you the final result, final model in a couple of minutes, or based on your data, maybe a couple of hours. So that's the result. You can see the result is between your GBM baseline and also the Kaggle Grandmaster Best. It's not far away from there, but we are still working on that.
So what you're saying is it's cheaper to buy your product than to hire premium.
Exactly. Yeah, that's another point. So so this tool is to help your data science team. Sometimes I call this tool some kind of enlarger. They will enlarge your ability to do more modeling stuff, to focus on your business side. Like, typical use case, maybe with one team of senior data scientists, you finish a product, data science product in maybe, let's say, 2 or 3 months. And then plus the pipeline development will be another month. 3 or 4 months, you finish that one. But with this tool, maybe with one data scientist, with domain knowledge, they can get it done in a couple of days, even a couple of hours. Yes?
Are there any reason why for Amazon, there's like a 10% gap?
Yes.
Are there why that specific context have a larger gap?
Yeah, I believe for the Amazon one is natural language processing use case. So we have natural language processing elements in our Driverless AI, but for that special case, I guess we just, we still have something to catch up. Yep.
Like, are the future engineering, are they explainable, the variables,
Yes.
It's not like just getting the accuracy, you have to explain what you have used.
Yes, definitely.
Kind of.
Yeah, definitely. I will have one slide to show that, and also you can see that in your lab by yourself. Let me just quickly go through automatic visualization. You will do this by yourself later. This is the machine learning experiment. Inside of Driverless AI, when you run your experiment, there are 3 main knobs you need to set up: accuracy, time, and interpretability. So accuracy will decide, what's the maximum rows we will use, for each round of testing. And also, do we do target encoding? Do we do target transformation? How many faults we will create for cross-validation, this kind of stuff. And the time will decide how many iterations we will run. And each iteration, what's the early stopping condition, this kind of stuff. So interpretability will decide mainly our feature engineering effort. When you set up these knobs inside of your lab, you will see the summary on the left panel. We will do that together. The whole workload, let's just quickly go through this. So after you give us the data, we will do feature engineering. We will do model tuning. So model tuning means actually we will try to search your hyperparameter space, try to search different categories of methods like GBM models or GLM models or rule-based on models like rule-fit models. We will do a big search in different categories and then try to figure out what's the features which to use for each model, what's the best model based on the criteria you want to use. Yes?
Isn't feature engineering somewhat model dependent?
Yes, that's why, actually this picture maybe is not very good. The feature engineering and the model tuning, they're together. It's not separated, yeah. Good question. Scoring pipeline, you will try this by yourself. And okay, the last slide I want to show is the interpretability. We already talk about these. So when you build a model, we have automatic feature engineering. So just like this slide shows, you will see that we have so many engineered features, generated features in your final model. How can we understand what's the meaning of that? That's the question about machine learning interpretability. We have several techniques that will help you to understand the model. Mainly, we have feature importance. We have Shapley. Especially Shapley is extremely popular in explainable AI, this area. That will help you understand what's the impact of each variable to your final model clearly. And also, we are building surrogate models. If you are familiar with K-Lime, you will know K-Lime is the most popular surrogate model method people are using for machine learning. By using K-Lime technique, you will get some kind of reason code to help you to understand for each single row, what's the reason we get that prediction result. What's the impact of each your variables. Of course, you can just learn our customer stories. Go to our website, H2O.ai, customer stories. There are tons of them. You can study there. Yeah, let's just quickly go to the lab. You don't need to do anything, and then you don't need to download anything, but you need to go to your web browser. The Google Chrome is recommended, but you can try others. Just go to your web browser, go to aquarium.h2o.ai. If you don't have the Wi-Fi connection, here password is meetings or lower number meetings. Okay, when you go there, you have to log in. I guess you already registered before, so you should have your username and password. If you don't have, just use your email address to log in and then try to register. You should get your password in several seconds. Aquarium.h2o.ai, and then just log in. So any trouble or anybody guys there? Okay. And then, meetings, lower number meeting. No, after you, yeah, you need to register by using your email, personal email. Yeah, if you have not done that yet, just register by yourself. Using any email, you will get the password, username. Yeah, let me switch to the website to do it with you. Okay, this is the web page. I mean, for me, because I'm using my own email, I will just after you log in, you should be seeing this page here. Just click on Browse Labs. And then click on the first one, View Details. The first one is Introduction to Driverless AI, 1 GPU. If you click on that, you will see actually the summary here. We will start one AWS EC2 instance. It's a P2 extra large. You will have 2 hours to run this lab. You can just start lab. If you are already here, just click on Start Lab. It will take a couple minutes to launch one instance on Amazon and then give you the address. After that, you can click on the address to be connected to Driverless AI, and then just use default username and password, which is actually H2O.ai. Let me see the instruction here. For the Driverless AI, username and password, they are both H2O. Yeah, after you log in, just browse labs and then just go to the first one. View details, the first one. The first lab is Introduction to Driverless AI. After you go there, click on Start Lab. It will try to launch a EC2 instance on Amazon. In the meantime, you can go through the details by clicking these 2 links here. Automatic machine learning tutorial with Driverless AI, and also model interpretability tutorial with Driverless AI. So those are the 2 labs we are going to do today. Actually, my plan is I will give you maybe 30 to 40 minutes to finish the first one, and then we have 20 minutes Q&A where I will just walk around. If you have any trouble, let me know. And the 20 minutes Q&A, I will try to answer all your questions, and also I will try to show extra demos if you are interested in any other features included in Driverless AI. And after that, you can go to the second one, which is the model interpretability lab. You can, the same thing. 30 minutes, you can finish the lab, and then I can use 20 minutes to explain everything. And also after that, if you have your own data, you can try it yourself. This is a public, instance on Amazon. So if you have your data on your own laptop, or you have your data somewhere on S3 or anywhere you have internet connection, you can grab the data, drop that one to the instance, and then run your own experiment to see how it works on your real world data.
Should I have license key or no?
Yeah, we have license key.
Would it work without requesting license key?
They will ask you for the license key. Here, we generated a 2-day license key you can use. Let me just make it larger here. So just go to this link, bit.ly/dive into H2O. That's a Google Doc file. We have a license key there. After you log in, you need to enter this license key to start with for your Driverless AI instance. So in the meantime, when we are waiting, let me show you some real interface you will expect to see for this Driverless AI instance. After it's done, for me, I used a different system, but you should get a link. And then after you click on the link, let me just log out. You should go here. You should get here. And then for you, we will use H2O, as I mentioned, is the password. The password is, username and password for that is H2O H2O. Let me see if mine is deployed or not. Okay. Yeah, mine is already running. So you should get similar interface here. You can see a link after your lab is started. It's called Driverless AI URL. Just click on that. Just agree the terms and then use H2O, username H2O, password H2O. So after you sign in, you should see this interface here, and then just enter license. And then you need to go to that page here, bit.ly/dive into H2O. So this is let me just do it with you. Just copy the whole string. Then go back to your Driverless AI instance, paste in the license key, then click on Save.
How do you generate?
Generate.
There's a button on there for generate.
You mean this one here?
Yeah.
Oh, you need to go to the website. Here's the link. So bit.ly/. No problem. So the license key, again, the license key is in a Google document. But just go to bit.ly/dive into H2O. Open this page here. Open this page here, you will get these strings. Just copy everything here, paste back to your license key area in your H2O.ai, and then you should be able to get the main interface. Yeah, sure. No problem. The license key link. After you get this done, you can start the lab. Just follow the instruction from these two links. Just step by step. It's pretty easy to follow. Let me know if you have any questions, and I will just walk around to help you. Yes, in the link, there is a dataset. Titanic is a CSV file. Okay. Yeah, I mean, if you already finished, you can just go to, the login, you can just go to the link. You can read everything, but if you want to directly start, you can just, go to load data. In the middle, there's a download the Titanic datasets. It's just, if you go to the lab, you will see there are two links here. These are, two labs we are going to do today. The first one is the tutorial for Driverless AI. If you click on that link, you will get all the details, what you can do for this lab. Yeah, in the lab, there are two links. The first lab will be, let me just do it again with you. Here's the lab page, and then you click on the first link, Automatic Machine Learning Tutorial with Driverless AI, and then you will get detailed instruction about each step about this lab. What's the background, what's the dataset, what you should do step by step using Driverless AI. So by doing this lab, you will, experience yourself how easy to use Driverless AI. For a data science project, by using this tool, you can get it done in, let's say, half an hour or 1 hour. The whole process, including feature engineering, model building, deployment, packages, everything, and also machine learning interpretability packages.
Could you please kindly show the license link?
Sure. I'll put this one here.
But you have to go to the other link to get the file from.
Yeah.
So the file is where?
The file is a public file. If you just search for load file, task Titanic.
Task 3. Okay, here's the file.
Yeah, just scroll down a little bit. You will see the file link. Let me just quickly, maybe if you have trouble to load your file, I will just quickly do it here. So when you add this, tutorial link page, you can go to load data, that section, task 3, and then scroll down a little bit to download your file. Just click on Titanic set, that link. After you download, for me, it's already in my downloads folder, and then just go back to your H2O interface, and then either drag and drop. You can drag and drop.
I entered the license key now. I mean, it says that expires in 1 day.
Okay. Doesn't matter. I mean, you will have, just click on OK. Here. Did you paste?
I did.
Okay. Paste. Yeah, save.
It comes up with 1 day.
Yeah, it's okay.
It didn't do that. Okay.
Yeah. I think you're good to go. Yes. What's that? H2O, 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 H2O. Yeah, sign in. Yeah. No, you have to download from the link. Do you go there? Click on, where's your task? Just scroll down. Task 3 is load data. Yeah, down a little bit. There's a link here. Yeah, just click on that, download it, and then you can upload to the server. Yeah.
Can you show them how you obtain data set?
Yeah. So you need to go to the tutorial page and then go to, if you starting from the beginning, just click on task 3, load data. And then you scroll down a little bit. There's a link for Titanic set. That's a CSV file. If you click on that link, it will download this CSV file to your local. After you do that, you need to go back to your H2O instance and then click on Add Dataset, Upload File. Then choose the file downloaded. You can go ahead to just follow the instruction to finish all the steps, but here I will just, do the same thing on the screen if you are interested in. Yes.
So this interface that you have here, before this launch experiment, it was an interface that looked like that.
Mm-hmm.
Am I doing something wrong?
No, it's totally fine. So
because all I did was enter this, and then I didn't get options for any of these.
I think you already did. Let me double check because you selected or target column as survived.
Right.
And then all others, they are fine. So there are options. So, I mean, I will just go through the options here, but probably some people already reached out to here. I mean, this is the interface you can use to build your experiment. So for me, let me just start from the beginning. So I have our data set ready. I click on my, just click on for action. Either click for action or you can go to experiments to build a new one. Either way is fine. So from your data set, click for action, and then I want to predict. So for this simple project, we just want to predict the survivals. So survived, target column is survived. And then, if you want to drop any column, you can do that. I mean, for example, the ID column, if you think that's nothing about, the modeling, you can drop it. But we can automatically detect what's your ID column. And then we will not use that variable in the model building process. We can just start from the simple model with everything in. I mean, we target our survival, that column. And then, as I mentioned, there are 3 knobs you can play around with. Accuracy, you can turn it down or up. And then time, you can turn it down or up. But after reading your data, we also give you some default setting. Like, if you don't change anything, you can start. You can change values here. You can see that when you change values here, we will have the summary on the left panel here to tell you what's going to be running in this experiment. If we change accuracy, you will see, the feature evolution part will change. The final model pipeline, it's a single model or ensemble model, it will change. And then time, when you change the time, how many rounds of testing we will run, that will change, and also as well as early stopping condition. So when you change the interpretability, this part will show you what's the engineering effort we will put there. You also have some kind of more complex thing. You can have a look, which is expert settings. Under this expert settings, you have more choices. You have the flexibility to turn on or off for certain models. And then you have lots of other advanced parameters that you can tune. For example, feature engineering effort, or maybe do you want us to look at if there's any difference between your training and testing, and also like the maximum number of rules for roofing models, all this kind of, lots of things. But here, actually, if you want to get more information, just go to our docs.h2o.ai, docs.h2o.ai, and then go to Driverless AI menu, user guidance. You can find every detail here. Just let's just scroll down a little bit, go to experiment settings. Let me just search for expert settings. So in expert settings, you will see all the details about each field. By the way, I mean, documentation, the best place to find documentation is just docs.h2o.ai. Let's just switch back. So after you set up everything, just, launch your experiment, you should see this interface here. So this interface, it will come up a couple of seconds. For the left bottom, you will see the yellow dots, some lines. For each line, that's actually a round of testing. For each round, we will test several models with different combination of the features and models. Like here, you can see each yellow dot actually is a model. If you just move your cursor to the yellow dots, you will see the variable importance for that one. And also you can see the CPU usage, memory usage, and GPU usage here when it's running. And because this is a classification problem, you also can see the ROC curve, the PR curve, the lift, gain, all these kind of statistics about the final model. I mean, the latest model we built. So we will do like, based on my setting, I will do like 116 rounds of testing. For each round, we are running different models to test. And then finally, we will give you the best model with the features, correct features. And then we give you, the report about what's being done. So I guess everybody is in this page right now here, right? Or anybody has trouble to getting here? Okay. Yeah. So you can choose different settings, change them, or you can just launch your experiment.
Oh, okay.
Yeah. No problem. Yep. Which one?
Why is this number?
What's the question?
116 iterations.
Yeah.
Because it's automatically calculated.
Yeah. The question is why we have this 116 iteration setting here. So actually, this is generated by the time setting here. I use the 6. Maybe you use other numbers that will decide how many rounds we will run here.
This time in seconds and minutes.
Here?
6. You said times.
A time. It's a knob. It's a scale between 0 and 10. So all the settings like accuracy or time or interpretability, they are numbers between 0 and 10. When you set up these, they will change, as I mentioned, accuracy will give you, how many rows we will use for each testing, and also what's the final model, is a single model or ensemble model, as well as, what's the models we will use to test for each round. Time will decide how many iterations we will run, and then what's the result you will get. I mean, what's the early stopping condition. Interpretability will mainly decide what's the engineering effort we will put, how many transformations we will try. So actually, the higher the interpretability, the lower the engineering effort we will try, because we will generate less, derived features. That will make your model more understandable, just using more original features.
But you can tune all these 3 parameters yourself?
Yes, you can tune them. I mean,
but I didn't see you tuning, so it's already.
I did that. Let me just do it again. So when I start a new one, you can change these numbers, just whatever you want. The default is okay. Default is the suggested numbers we give to you based on your data, but you always can change any number. When you change it, you will see the summary on the left panel to tell you, what's the models we are going to run, what's the testing strategy, validation strategy, what's the iteration time, what's the interpretability, feature engineering effort. As well as, I talked about expert settings. There are so many settings. We don't have time to go through area of them. Just, go to the website, check the documentation if you want. So by tuning the parameters inside of expert settings, actually you can tell us what kind of model you want us to run, and then, along with other advanced settings. For example, I can turn on roofing model, I can turn off GLL model, or I can turn definitely on GBM model or let GBM, whatever you want. When it's running, another thing I want to mention is actually for driverless AI, we are putting so much effort on that. Every 2 weeks or maybe 3 weeks or maybe at most 1 month, we will have some kind of new release with new features. you can go to the documentation to check. For example, maybe we just add time series and the natural language processing packages in last year. We are adding more on the roadmap. I see from the engineers' roadmap, we will, right now, Driverless AI is running on a single server environment, either in cloud or on-prem, but we are working on multiple server setting. It will be running in a cluster with multiple servers by the end of this year. We will have a new version coming out. And also, we are enhancing our documentation part. I can show you some example of the documentation you can get after your experiment is done. We are also working with our customers to enhance that experience. For example, we are working with Wells Fargo to get a very detailed, banking criterion. I mean, they have a template, like, for each experiment, we would generate like maybe 100 or 200 pages of the documentation talking about all the details. Those details are required by a model validation team inside of bank. So all these features, we are adding more and more. Just check docs.h2o.ai to get the latest release information. When it's running, let me just show you one example about what's the documentation you can get after your experiment is done. Let me just go to my instance. Here. Where's my pedal? Restart. Looks like my instance stopped. Yeah, I have my own instance running on Amazon, but the setting is I set up like, after 1 hour not used, they will just shut it down. Otherwise, it's just waste of money. But just like, I mentioned, it's pretty flexible to deploy this software to anywhere. Amazon is a very typical host for Driverless AI, as well as I know lots of customers, they are using local on-prem servers in their lab, or Google Cloud or Azure Cloud. We support all of them. It's just we are a software platform provider. It's not specific related to any hardware or environment. We support both GPU and CPU. I mean, of course, the algorithms, most of them, they are optimized to be running on GPUs. If you have a server with multiple GPU cards, we will do the parallel calculation, distribute the calculation to multiple GPUs. But if you have only CPU environment, we are also working on that. Of course, Intel. So we are working with Intel to optimize the calculation, make it, running faster. Let me just restart my instance. I can show you what's the report you expect to see after your experiment is done. Oh, this one is almost finished. Let's just wait maybe for 1 more minute to get it done. So you can see here why it's finished before 116 runs, just because it's hitting the early stopping condition. After early stopping condition is decided by the time setting here, maybe after like 7 or 8 rounds of testing, there's no improvement about these models. We will stop and then give you the final model, as the best model. Yeah, because the criterion, I use the default one, which is the AUC. Based on your classification, you can choose other criterion as well, like Gini coefficient, or maybe F1 score, or maybe log loss, or the AUC PR, whatever you are choosing. We will use that criterion to do the testing on holdout data in your training data set, and then to make sure the performance is to test the performance. If the performance on these data sets they are not improving, we will stop there, give you the final model. So if you are already done, you can just go ahead to finish the rest of the lab. I mean, we still have, you can go through the machine learning interpretability. You can just have a quick look at the report. There are several things you can do there. I will wait for my instance to, experiment to finish, and then just quickly show you the report.
And the GPU usage is already 100%, yeah? The line.
You mean CPU or GPU?
GPU.
GPU here, yeah. That's the peak, yeah. We will have some peak time using 100% of the GPU, but we will have some gap, during these iterations, we will have some, handling by CPU or GPU both. So we will just handle the data. Generally, we will generate, do the transformation using CPU, and then when we are running modelings, we will just throw them to GPUs. Yes. Let me just check. It depends on the setting. If you didn't, yeah, for me, because starting from the beginning, we tested different, models, and then I think driverless AI for this use case, we think GBM is the best methodology. So we test more GBM than GLM. But based on my expert setting, let me double check. I turn on GBM, let GBM, GLM. I didn't try TensorFlow. I didn't try RuFit. I didn't try FTRL. But you can turn them on to ask driverless AI to try them. But so far, because automatically we will try GBM and GLM. Looks like for this special use case, driverless AI thinks GBM is the best model. So that's why they are trying more GBM with different features, with different hyperparameter settings.
So the expert settings enable you to constrain which model it might try.
That's correct. You have the right to choose what kind of model you want us to try.
Well, it'll try anything you allow.
If you set up auto, we will try it. You can turn it on or off or auto.
Why not in theory just allow everything to be auto and let it select?
It's the balance between the running time, the resource you have. If you have a single GPU like this, I will not try TensorFlow for this simple classification problem.
But if you have multiple GPUs,
if you have a more powerful machine, you can try more.
but wouldn't your automatic algorithms determine that anyway?
You mean based on your resource, decide what kind of? We are not there yet. So it's still we need some human being to interview. Yeah, sure. Yeah. Driverless. Correct.
I can drive a
Yeah.
trailer truck.
You can sleep when the car is driving. Yeah.
I can do that. I can do.
Is there a way to constrain how much time you have?
Exactly time we don't have that because estimation of the running time will be based on several things. All these three knobs: accuracy, time, and the interpretability, and also some kind of settings under expert setting. So we can give you an estimate. When you start your experiment, you will see the estimate on the left panel, the bottom, how long time it will be running. But based on that, you can just change different parameters, tune this kind of knobs or expert settings to get your expected running time.
So if you discover it's going to just take way too long, are you better off stopping it and changing those settings, or just do some early stopping because?
Yeah, let me just show you the real. So let's just build a new experiment here. So you can see one. Let me just select my survival. You can see here on the bottom, we have estimated running time is minutes right now. If I turn this interpretability to very low and then time to very high, this is a small data set, still minutes. I mean, that means less than like maybe 10 minutes. That's the estimate based on your settings.
So accuracy doesn't affect it.
Oh, it's. Sorry, what's the question here?
Because you have accuracy also, you didn't change it.
Okay.
Yeah,
The question is, I didn't change the accuracy. So I mean, yeah, no problem. So actually, of course, I can. Let me just. Extreme case will be we turn accuracy to 10, we turn time to 10, we tune interpretability to 1. You can see estimated time will be changed to hours right now. So because by this setting, we will try everything. We will try all the combination. Also on expert setting, you can turn on or off for all these models. So the version you are running right now is, if you have a look, it's 1.5.2. Our latest version is already 1.5.4. It's released like maybe 1 week ago. In that new release, some difference will be like under expert settings. Right now in 1.5.2, Roofing model and the FTRL model, they are still alpha. That means actually you can use these models, but we won't give you module scoring pipelines. But in the recent latest release, they are already formal. I mean, we don't have the alpha comments here, so you can use them for anything. Yes. Yeah. Let me see. Mine's still not done yet. Let me just use. Yeah, it's just that's just some kind of estimate of the completion. I mean, right now I guess it's let me just quickly check the log. Yeah, I mean from the interface, if you click on log, you will see the details, more details, technical details. But generally, I bet you don't want to go there. But so let me just have a quick look. So right now is the latest one is. Information pin from this one written here. So the GPU is only 1 GPU, memory usage. So AutoDL final model pipeline. Okay, right now they're trying to build the final model pipeline, which is for this use case. Let me double check my setting. For this case, it may be a stacked model. If it's a stacked model, they need to grab the information from previous running experiment to generate the final model pipeline. It's not only generate the final model, but also generate the scoring pipeline, which is a Java and the Python package that you can deploy later on. That will take some time, but it's still running on the final model. This 99% is some kind of indicator that the testing iterations they are done, but we're working on the final models. Let me just log into my instance. So anybody finished this experiment, or you are not done yet? Let me just using my instance to show you what's the report looking like. What I'm doing here. Okay. This is my instance. Password. So when your experiment is done, you will get something very similar to, let me see if I have, maybe I'll just grab this one. You will get this interface. So this is a experiment I was doing using a different data set, not this one, but you will get similar thing. So you can go to download your experiment summary. You will get this button here. Click on that. You will get a zip file. Just open that zip file. Inside of the zip file, you have lots of files, but the main thing is you can go to report. It's a Word documentation. So in this Word documentation, you will see all the details, like, from the summary to all the details. Like, what's the model being evaluated, what's the features we generated, what's the features used in the final model, what's the performance of your model, all the details.
And the code in Java or C# something after the experiment is generated and saved in the same directory or how it works?
Yeah, the question is, what's the code, after doing this, and then how can we work with that? So in the backend, actually, our main code, there are CUDA code, Java code, and C++ code. But after experiment is done, as I mentioned, we will give you two packages. These are here. It's the Python scoring pipeline or module scoring pipeline. Those are the two packages you can deploy to your production environment. You have Python or Java available.
Does it include the data?
These packages, let me just give you one example, quick example here. For example, the Python example. It will take some time. It's a big one.
So is there explanation for all these variables, like what is 3 underscore code 3?
Yes, good question. So the question is, how can we explain those variables, like the COR3 or medium? But those for this, I used a different data set for this. Let me see if my experiment finished or not. Still running there. Single node. This is a EC2 P2 extra large instance, so it's not a big machine. It will run some time, but let's just go back to the report we have. This is running on a different data set, but you will see the explanation in feature transformation section. So for example, let me just make it bigger. Single page. Okay, you will get a similar report after your experiment is done. So you can see the original features. We would put original features there. But if we have engineered features, you will get some explanation about what is that feature, along with the relative importance of that feature.
If we happen to abort the process because it's taking too long to run, will it still create like an intermediate model, or will it stop?
No, it will stop. You have to, no, we don't give you the model if you abort that one. No. Yeah. No problem.
Thank you. Can you put it on wait?
You mean?
I'll come back tomorrow. I don't want to.
Put on wait.
Sleep.
Put on sleep. Generally, I don't think so. So think about your real life. Think about your real life. Right now we are running a real-time, experiment, but think about your real life. Maybe you can just kick off the experiment before you go back to your home, and then second day when you go to your company, you will see a done experiment. You can read the report, get everything done. So you don't need to stop it. It will be running there. Yeah.
Because consume resources, let's say in cloud, then you have to cover expenses for that.
So that's covered by the software. Actually, I mean, in the cloud, there are lots of settings like, maybe after 1 hour of unused time, they will stop that instance. That's very possible. Yeah.
What does the variable importance of one mean? Does it mean that it's the most important?
Yes, that's correct. That's based on the variable importance. I mean, the variable importance is coming out from the tree based on model. I mean, the first split, the most important variable. That's, yeah. Yes.
I didn't see it when I was making the expert settings or the experiment settings, but is there an option to disable some of the models that I don't want to test it against?
Yeah.
Like I know for something like this, I'm not going to do like an XG boost or
Yeah.
It's a little too much for this data set.
Yes.
Can we disable those stuff?
The question is, can we just disable any model? I mean, so of course. Yeah. Let me just quick show you. Already. Let me just quickly.
It might be an option. I just didn't see it when I started.
Yeah. So we start from here. I use the same thing on the same machine, but I will show you. We select target column, and then we go to expert settings. I don't want Driverless AI to try XG boost. I turn it off. Yeah, just turn it off. For example, maybe I think GLM, I mean, linear model will be best for this one. I turn it on, and then I turn others off. By this setting, we would only try GLM. Yes, of course. Yeah. Yeah. I'm sorry. Yep. Sorry, yeah. What's that?
If I want a parsimonious model, is there any way to specify this?
You want what?
Parsimonious model. So not including too many variables, it should just pick the most important, but try to keep the number of features that we use as small as possible.
Let me just try to understand your question. So you want to try just fewer model, but
No, select models that use fewer features, but I mean the balance between accuracy and how many features I include in my model.
Okay, the question is how to balance the accuracy and also the features generated from Driverless AI, right? Or
how many features it picks?
so that's decided by several things. The question is how can we balance the model accuracy and also the features generated? I mean, so by tuning this interpretability when you start your experiment, you can see the summary here. We will have some summary here, what kind of transformation we will try. The lower of your interpretability, the more feature engineering we will put there. We will generate more features and then testing these features in the later iterations. Yes. Yes. So interpretability actually will decide what kind of feature engineering effort we will put there. So the lower of your interpretability means we will generate more features. We will get more derived features and then. That's correct. Yeah. Yeah.
So now I know I'm moving into being like assisted AI, driving AI rather than driverless. But let's say I'm fitting random forest to this model. I know once I've selected that, it's going to try out different options from the grid search. But does it also give you the option to decide what parameters you're actually trying different values for? Things like depth of the tree. I know this is kind of like you're basically more than the hyperparameters, actually just the parameters in itself, like the depth of the tree, the sample size. Now I know this is very similar to basically writing sklearn and what's happening behind the scenes. But if I don't want everything to be tested, can I also choose the parameters?
The question is, can we specify special parameter range for a certain model? Like random forest, we know we will limit the parameters to certain learning rate or depths or number of trees, this kind of thing. So
also when you're doing a grid search, I don't want the grid search to happen for all the parameters. Maybe I just want a few of them to be in. So I know this is very much like getting into assisted AI, beats the entire purpose. But as an engineer, that might be something that I might be interested in.
Totally understand. So I mean, the answer is right now we don't provide this kind of we provide some options, but not that much. I mean, you cannot control all the details, like, for each model, I mean, or for each big category, what's the hyperparameters you want us to try? Like, on our open source side, we have AutoML, that function. You can specify what's the parameters you want us to try, but Driverless AI is a tool designed to, simplify the whole process. So we have to get the balance between the simplicity and also flexibility.
Yeah.
Right now, we don't have that kind of control.
No, I was just trying, I know this is a little too specific, but it was kind of like saying, can the Kaggle Grandmaster actually use this to, rather than actually doing the code, use this to just adjust the settings because, he's done his bunch of analysis and then just run this. That's not going to happen with this.
Not really for everybody, but I know some use cases like some customers, they are using this tool mainly for feature engineering part because the feature engineering, the transformation will take a long time in your modeling process. They just use this tool to run it to figure out, what's the best engineered features coming out for some model, and then they will use these features to build their own model. Yep.
Like my question is the same. Like for example, you showed us like 10 to 15 features, right? If I want to drop some of the features and like run the experiment, can I do here, or like I have to take the variables and?
So after you get your experiments done, let me just click on one of my built example here.
So for example, the third variable is maybe tough to explain, like what it is.
Yeah. Let me just quickly pull out one. So if you get your experiment done, there's one option here to transform another data set. So by doing that, you provide us your raw data set. We will do the transformation. We already did, in this experiment. We'll give you a transformed data set with, all these new features. You can use that one to try your own model if you want. Is that what you are asking, or? Okay. That's on your own, yeah. So we give you the best model based on the result. But if you want to try your own model based on transform the features, you can get it from here. You can do the transformation on your new data set and then grab the data set and then run your own model based on that features.
Do you learn from the previous one? Like if you put a new data set, do you learn from the previous one, or you start analysis from scratch?
You mean your own, or you build another?
I already run that data set and I already get the whole set is complete. If I put another data set, will you learn from the history?
So the question is, we build an experiment already, and then you have a new data set coming in. Do we use the previous data set to learn the patterns? The answer is no. I mean, when you build your experiment, that's totally decided, depending on the data set you are bringing into that special experiment. We don't look at any previous information. Yeah, question here?
Is there anywhere where you can specify, like, I want to treat this feature as categorical, don't try to turn it into numeric, or like?
Let me think about. So far, probably not. You mean you have some numbers, but they are, or you have, but how can you, for example, categorical variable, generally there are strings or something, so how can you use them?
But don't try, well, obviously it has to be encoded into a numeric, like one-hot encoding. But when you're saying, like in this, when it like engineers the features numeric to categorical or vice versa.
Yeah.
How is that actually working? Like, how do you take a numeric feature and make it categorical? You're saying like you do one-hot encoding for all the different.
So the question is, how can we deal with the categorical variables? How can we convert them to numerical variables? Is there any control of that? The answer is you can control them in some level. When you build your experiment, let me just start a new one. Let me just maybe start from the same parameter here. You can see when you start a new one, the interpretability, if you turn that one to very high, let me just show you one more page here in my presentation actually. Okay, let me just make it smaller. This is the interpretability. Let's go to 100%. Oh, it's too small. Okay. So this is the interpretability explainable table. Like, you set up interpretability between 1 and 3. We will not do ensemble. We will, the feature, there are several things we will disable. But generally, if you don't want us to do lots of target encoding based on your categorical, you can turn interpretability to 10. That will make us only do one hard encoding on your categorical variables. Yeah.
Yeah, one of the ways that I've worked with this problem is that I first changed them to binary on-off for each category, and then develop a model, and then take a genetic algorithm and do a search for values which improve the model. So you use a genetic algorithm to actually get a numeric value for each one of those little dots you turned on and off. That may be hyper tuning, but.
So can you repeat? I don't follow you. So you said for each one, a binary value. For each category. You mean categorical variable or?
For each, no, for each, the categorical variable is gender, and there's male. And there's
okay.
Female. Now I could have put in 2, 0, 1, 2 on-off neurons if you care to look at
Oh, okay.
But then to go further, to actually find a better value to put in there than an on-off, you can use a genetic algorithm to search for a better value.
So the question is, if we look at, for example, sex, we have male, female, these kind of categorical variables. General method is we call it one hard encoding. Based on how many unique values you have for that value, and then we create the number of that value minus 1 different values for that, one hard encoding. For us, we definitely try that. That's the baseline. And then after that, we also try target encoding, which is more advanced, feature engineering effort for this kind of categorical variables. So it's based on, you can search for, let me just go to show you some documentation about that. Yeah, let me just quickly show you a place you can find more information. You go to our website, docs.h2o.ai, go to Driverless AI, and then you can find transformations. Search for transformations. You will see the Driverless AI transformations, and then from here, for categorical variable, we have several things tried, but mainly you can look at target encoding. Let me just search for target encoding. Yeah, cross-validation target encoding. This is the main method we will try, and also you will see some examples after the explanation.
Excellent, thank you.
Yep.
Yeah, I have to read about that because, it might be something that I'm not aware about, but if you are associating a numerical value with a categorical variable, which does not indicate just absence or presence of that value, you're actually putting more meaning to it. Numbers have an order to it.
Yeah, you're forcing it to fit to better do your model.
But
that could be data related. So.
Yeah, but categorical variables do not necessarily have an order. Like male and female, there might not be an order. So if you put a value like 0.5 and 0.6 to one, all of a sudden you're bringing order into a
not only you're bringing order, but the mathematical functions.
Yeah, and that might, I don't know how to filter. But I had.
It's kind of like what neural nets do with the 0, 1.
But I had another question. Sorry about that.
No problem.
So we talked about feature engineering. How are we handling, I was wondering if there was something that you do about the actual data in itself, missing values and things like that. What do you guys do about it? Like, is there a choice to either replace it with a value of, it could be a predictive value that you're replacing it with. So can you connect two models or two experiments saying the output of one actually goes into the input of the other and build a pipeline out of it?
So the question is, number one, how can we handle missing values? Number two, is there a way we can connect, build a pipeline, like, using the output from one experiment as the input of the other experiment. So for the missing values, we can handle missing values. I mean, if you have a better way, you know how can you impute your missing values, you can do that yourself before you pass the data to Driverless AI. Otherwise, you leave the blank there, you leave the missing value there, we can handle that. We will impute based on different technologies, like maybe we will build a regression model to try to figure out what's the missing value, or maybe we will use a generalized low-rank model to impute that value and then go to the next step to test what's the best way. For second question, how to connect two experiments. We don't have an option to do it here. Maybe you need to do it manually. Like after you build a model, you get your screening pipeline, and then you get your raw data. Just run prediction function on that raw data. You get your predictions. You need to combine the data to run the second one. So, but because for each experiment, we will give you the scoring pipeline. So actually, those can be handled, backend using your Python or Java, whatever the code you are using. Yeah. Yes.
Where do I access the final model? I mean, like I see that if depending on the configurations, you can, if you have more accuracy, you can embed, like you can stack or like the examples. Where do I see the final stack of the model?
Yeah. Yeah. Good question. So the question is, how can we see the details about the final model? If that's an ensemble model, I mean stack model, how can we see how many models are there? What's the detail about these models? These are in the report. I'm not sure. Let me just see if my model finished. This is my own instance. Oh, it's finally done. Okay. So when it's done, you can go to download your experiment summary. When you open this summary, just go to report. And then the final model, let me see, in this version, do we have the final model detail? Should be at the end. You will see your final model. Let's go to the end. Summary of columns shown below. Training data. What's this? No, I won't go to the end. So if you go to the end, you will see the final model detail. The final model for this special experiment is a light GBM model with the following settings. So these are the hyperparameters we use for the final model, and also you get the variables used in that final model with feature importance. Let me see, where is that part? Yeah, from here. If you go to the middle part, there's one part called feature transformation. Let me scroll here. Feature transformations. You will see the features used in the final model with feature importance. Yes?
So basically, when we run this model, it comes up with a CV target encode transformer.
Yeah.
Can you explain that?
Okay. Cross-validation target encoding transformer. So if you go to, that's a technique people are using for categorical variables. One-hot encoding is okay. It's a general way. But I would like to say for most of the cases, one-hot encoding will maybe bring in some kind of overfitting problem. It's too detailed about each value. So that's why sometimes people are using target encoding. That's a long topic, but for target encoding, you can read the example in our documentation here. Just go to docs.h2o.ai, search transformation. We have example transformations. We will have the explanation here how to calculate target encoding, transformation. Basically, that's based on the frequency of your value in your, categorical variable. For example, you have A, B, C, D, 4 values, and then what's the frequency of A? What's the mean of A based on your, target column? And then we create cross-validation, for that, and then we take the mean for cross-validation false. And then we based on that mean, we create the new value for that. Yes.
You're basically putting a response variable as a covariate. That's why I'm not following it. It says the lead is mean of the response column for each value of categorical.
Yes. So we use that one as a feature coming out from your ABCD. For ABCD, I mean, think about this. Categorical variable ABCD, we have to convert them to some kind of numbers. 1, 0, 1 for A, 0, 1 for B, 0, 1 for C. That's the one-hot encoding. This is one way. The other way is we think about, how many A's will affect your final prediction. That's the mean of A. And then based on this principle, we can create cross-validation, calculate the mean for each fold, and then create the frequency for that. So this is another way to convert your ABCD to some kind of numerical value.
So you see for A, for instance, 60% of the time you have 1.
Yes.
Putting with the response variable, the target variable. And then B, you have 70%. You think AB may have like 80%. And you're putting that 80% as a...
Very similar. It's not exactly because we are also considering the cross-validation, but that's a principle. We consider the mean of A, of your target variable, as a value for A. Is that clear? Or yeah, maybe you just read that one. I mean, you will understand. So this is just one technique people are using to convert your categorical variable to numerical ones. In my personal experience, I think it's working pretty well for GBM, even for JLM. But we are testing both. We are testing the one-hot encoding. We are also testing this to figure out which one is better for the final model. Yeah. Sorry, that gentleman first. Yeah.
When I download the Python scoring pipeline,
yeah.
I get a rather large zip file.
Yes.
There are several Python source files. Which one of those Python files is the actual model?
Okay. Let me just show you a quick demo about how to use the Python scoring pipeline. That's probably will be interesting. Let me see. I already downloaded it here. So after I open this package, I think this gentleman's question is, there are so many files. Which one is the real model calculation part? So firstly, I think you can just have a look at the README file. README file will give you the explanation what is the content in each file. And then most importantly, you can open example.python. So for this example, we will give you some example Python code about how to use it. You can see the main code here. Let me make it bigger. Yeah. Yeah. Yeah, on our website, the question is on our website, do we have examples? Of course, we have examples. You can go there. I mean, let me just quickly show you the website example, and then we will go back to this file. So go to website, go to Driverless AI documentation. Let me just go to from the beginning. So docs.h2o.ai. Go to Driverless AI user guide, and then go to deploying, the Python module scoring pipelines. So you will see examples here, all the explanation and the examples. But quickly, let's just make it bigger. Let me see. We'll, yeah, try that. It's not working on here. It's, let me just make it window. Let me see, where's the, here, yeah, maybe just there. Yeah, you're right. Okay. Let me just hide this part. Okay, you can see the main, thing in this Python code is we give you a view file. If you just go back to we give you a view file here. You have to use just pip install to install this package to your Python platform. After that, you can import that package directly. And if you have new data coming in, for this example, I just, make up some new data. This is your original data, like city or something. It's not your Titanic data set, but it's another example. But you have your raw data coming in. After that, you just call some function to get your scores. Let's just go. So this is the data frame I get, and then I just call one function. This is the function inside of that package. Call this function, pass in your data frame with your original data, and then we will give you the scores calculation. So all the calculation, transformation, model calculation, they are behind, inside of this package. But this is a binary file. You cannot read the details. You cannot read the source code. Okay, please.
Is there a way to use the visualization tools on the model outputs?
There is no. So the question is, there's a way to use the automatic visualization tool on model output. Answer is no. That one is only working on your data set. You import it into your system. But for diagnostic purpose, actually, we have a new feature here. Let me just quickly show you. Not sure if you know that. So you can diagnostic model on new data set. For this one, let's just do it on my original one. For your real use case, probably you have a new one. But for this one, I just use our old one. So after you import your old one, they will try to compute. They will try to do the transformation, calculate, and then show you the diagnostic charts. Let me see why it's so slow, still running. Generally, this part is pretty fast, but this is a pretty small machine on internet. So let's see. That will take maybe, I guess, less than 1 minute. You will see the charts there. You will see the performance of this, model with different scores, with different, the AUC or all these kind of graphs. Is that you are looking for, or you want to look at the correlation or something, or what?
I was just wondering if you could use the same tools but using the predictions for that. But I guess some of them would be included.
Because this is different. So when you have your input data set, the statistics you need to look at from data science point of view is totally different compared with the prediction result. The prediction result, generally, people will look at for classification. They will look at the AUC curve, or the lift, or the gains, or maybe the confusion matrix, all this kind of statistics. But for input, generally, people are interested in if there are outliers or abnormal distribution for some certain columns, or maybe high correlation, between your variables. So for that one, we just cannot run that. Yes. Sorry, here.
For this tool, what support do you have for natural language?
Okay. For natural language processing right now, we only handle structured data. So you cannot pass us directly your audio or maybe your image or PDF. You have to already grab your text, content from there. But we can handle from there. So based on the text content, we will use TF-IDF, which is term frequency inverse document frequency. And also we will use word-to-vect to generate new variables based on that text column and then build a machine learning model.
So, I see that you have support for TensorFlow. So do you guys work on word estimating as well, or just talking?
So the question is about TensorFlow. TensorFlow is, heavily used inside of the natural language processing models. So after build word-to-vect, we use CNN to just build a model, try to figure out what's the best features coming out from that word-to-vect. That's the part we are using TensorFlow. Also, we use TensorFlow to, run some kind of multi-classification. Like if you have more than 5 classes in your target variable you want to predict, we will use TensorFlow. But that's, generally speaking, TensorFlow is not used for everything here.
If I give you just any Word document, will it be able to process it?
Any what doc?
If I give you a text document, so do I have to put it into some format, or can I directly give the document and it will give me the desired attributes?
So what kind of document you're talking about? Several pages or
if I give you one block, random block, so will it give me like what are dates it contains, if at all it has any date or something?
The question is if we get some data from text to a block from a text column to Driverless AI, what can we do? So yeah, I mean, as I explained, actually based on your text content, we will try to convert this one to different numerical values. There are so many techniques. The main thing we are used is TF-IDF and word-to-vect combined with TensorFlow, CNN network to figure out what's the best features, and then maybe from one text column we will generate like maybe 100 new numerical values, and then use these values to build your machine learning model in the later process.
Like basically, I was just comparing it with NLTK. Like in NLTK, you have like you can see in which form a word is coming. Like it's a word noun or anything. Like if it's an organization, it will give you data as well. So just like in NLTK, you have those features. Will this tool have that kind of feature?
What kind of feature you are talking about? I'm still not following you. You said
from NLTK, I can get like if particular word is an organization or it's a name of person, date, something. Like
you mean extract certain words from the text column, or what's the?
Into the document, it can track. Like, from the context, it can give you many different things.
So the translate package is also able to then classify a word into different categories. Maybe it's a pronoun, like a name. So if the text was something like, I don't know, Jack had or wish, it would say Jack is a name. Or if it said Jack works at a certain company, it would be able to tag it from. So not only is it deriving the features, it's also deriving a class for the teacher in a certain way.
So I mean, the question is still about natural language processing. So when we get some text, how can we get some meaningful variables out of that? Like, we figure out somebody is a name or somebody is some kind of certain object. My answer will be, so actually we are running word-to-vect. Word-to-vect is some kind of thing like that. So word-to-vect, by using word-to-vect, that technique, you can identify similar words, like, car. Maybe, for example, let's talk about a bank. So bank, this word, maybe based on your content, is highly correlated to, let's say, account, or maybe saving, or maybe loan. So if you have these words inside of your documentation, we can identify those kind of similarities between your words using word-to-vect. But I'm not sure, I don't see anything coming out directly to figure out, like, Ryan is a name, or Toyota is a car brand, this kind of thing. Yeah, the main, as I mentioned, the main methods we use here for natural language processing is TF-IDF and word-to-vect. We combine these two together to figure out what's the most important features coming out from your text column, but that's it. We don't use other techniques right now. Yeah. Please.
Can you return please to your test results when it's complete, the screen?
Yeah, it's already done here. Okay. Yeah, this is the diagnostic, feature I mentioned. You can run this model on any new data set to show you the performance on that new data set. So we don't have the automatic visualization on that, but you can run the diagnostic.
Yeah, but it shows different, there's different tabs, like yellow when it's complete. Yeah. Can you just shortly explain the difference on the top yellow tabs, yeah?
Here?
On the new data set, that diagnosis model.
Yeah, I'll go through all these options. Yeah, let me just go through all the options here. So the question is, after your experiment is done, what options you have? Okay, here, so you can interpret this model. So by click on this, let me just stop it. I don't want to just take another time to run it, but you can interpret that model by clicking on this model here, this button here. So that will bring in to MLI page. They will build machine learning interpretability inside of this model, show you the reason code. Actually, let me do that. And then while I'm doing that, I still can show you the experiment. Okay, I'm running the MLI in the backend, and second button is diagnostic. I mean, diagnose this model on new data set. I already showed you that. You have new data coming in. You can run this feature to see what's the performance on your new data set with all the statistics and all the charts.
So you don't change any parameters, you just fit this new data set?
Yeah, we just run the final model on the new data set and then show you the charts. So for score on another data set is just, different ways. I mean, this is the way you can score on your new data on the server side. I already told you we have different packages like the Python package or module package. Those are independent packages you can deploy to anywhere you have Python or Java available. But here, if you want to score just using this server, you can do that. Bring in your new data and then just do the score on here. You will get the prediction of your new data set. Transform another data set is the option you want to look at the transformation. You want to use engineered features to build your own model. You bring your own data set, and then you do the transformation. You get a new data set with all engineered features. And then you can use that one to just...
So this transform not a data set related to actually different experiment, yeah?
It's just do for the transform another data set, we just do the transformation. We don't do any modeling stuff. We give you the data that transformed, based on the feature engineering testing we did. And then you can, starting from there, to build your own model. And download predictions is just download the predictions of your training data set. Those are the scoring pipelines. And then you have the model summary. You have the logs. Yeah. Yeah.
So you may not have it, but are there any kinds of predictive uncertainties estimated on the predictions?
You mean the standard deviation of the,
So not in totality, but on individual predictions. So like infinitesimal jackknife is a technique used with random forest, but I don't know. You're getting, if you're ensembling, maybe you have some sense of the variation in the prediction.
I don't think we have variation of the predictions, but just as I said, actually, for machine learning models, especially for very complex machine learning models, there are tree-based models, and also if you are considering the stack models, they're even more complex. Generally, people are using the machine learning interpretability package to understand what's going on there. So that's, let me see if finished or not. Still running. Let me just cancel one of them while I run two of them. Yeah, but that's where you will see the machine learning interpretability. Like, let me just go to my instance to show you a little bit. Like this one maybe. Okay, MLI. So those are the packages we're using to, let me see, leading this OTC train. Let me just quickly grab one of them. Those are the packages people are using to understand what's the performance of the data in sense of, when you are running your machine learning interpretability package on your experiment, you will get this kind of main thing. You will have global feature importance. You will have global Shapley value. Those are the values, especially Shapley value. It will give you, some sense what's the important features in your final model. The impact is positive or negative. Actually, Shapley value is, this concept is, we keep all other variables the same, and then we change that single variable to do the prediction to see what's the impact. And then we compare. Compare with, we keep all other variables unchanged, and then we change a single variable to see what's the impact. That's the Shapley value for that single variable, and then we do the same thing for each single variable in your final model, and then we give you this chart. Basically, this is, I think, maybe the most accurate impact measure you can get out of box for machine learning. And also we have surrogate models like the K-Lime or Lime model, their Lime model. We build surrogate model, which means actually we do clustering on your data. So for similar data, we are building linear models. And then local linear models, we use that one to explain what's the impact of these predictions. I mean, like your variables to the predictions. For each single one, actually, you will see like this page, like the reason code. Like for this special row, what's the impact of your variables to there? I mean, the green one is the positive contribution. The red one is the negative contribution. You can see clearly for that special record why we give out that prediction. And also we have surrogate model tree based on models. Like, if you just look at simple decision trees, what's the split for that special record? I mean, the green one will be for that special one. You can see the split is from this variable based on this value here. Second split is from that variable based on this value here. Also, we are running local, which is leaving one out. Use that technique to tell you what's the impact of that, for that special record, what's the impact of each variable. I mean, it's the same thing, very similar concept to help you to understand what's the performance of your model on your data set. But back to your question, I don't think we have the deviation for each row at this level. I mean, what I can see for the customers they're just using machine learning interpretability technique to try to understand what's the impact of the model, what's the performance there. Okay. Yeah.
I see that for some classification problems, I usually get the probability. Is it possible to get?
Yes. If you download the prediction, that will be the probability. Yeah, because the cutoff is depending on your decision. You can make the decision of what's your cutoff, and then you can convert the probability to either binary value or the class, which class you want.
Yeah, this is another point because sometimes here is like for the reasons of use, you cannot maybe pick your.
Yeah, another thing I want to mention about this question. I mean, the question is about for classification, can we get the probabilities? Because generally, people will get probability, and then you define your cutoff probability, and then you convert the real probability to your binary values. Of course, we can do that. When you download your predictions, that will be the probability. Another thing I want to mention here is, in your experiment, if you go there, you can see if you go to ROC curve, you can see the best F1. So this curve is, if you define your cutoff, for example, here, you can see, I stop my cursor here. You will get your threshold. This is the score, confusion matrix based on this threshold, 8%. And then if you change your cutoff, you will get different confusion matrix.
That's basically what you call management decision.
Yes. Yes, it depends on business sense. Sometimes people want to capture the more, positive result, or sometimes they want to capture. Yes, exactly. But we give you some suggestions based on ACC and F1. So those are the, scores people are looking at for classification. You can just, move to some points that will indicate what's the best threshold for best F1 or some other measures. So if you can see, if I move my cursor along this line, we will change. If we define our cutoff as a very small number, almost everything will go to false positive about your errors. If we just move up, use a very large cutoff probability, more stuff will go to false negative. It depends on what's the balance you want to take, and then you want to take the risk, or you want more false positive or false negative. It depends on your business business decision makers. Okay, any other questions? Yes. Let me report. What kind of report you are looking for? So the question is, can you download the report from MLI?
Yeah, I only saw laws on that section. So you see how you show us the different models associated with the Shapley feature codes different models. And so how do we, I guess?
So you want to download the pictures, or, I mean, so actually for MLI, you can download the reason code, which is, let me just show you again. So for each individual, you will get the reason code, which is coming from K-Lime. So it's the local linear model telling you what's the contribution of each value, in your data set to the final decision. But for the pictures, actually, we have some pictures inside of your report. But for the pictures, actually, you can download each picture if you want. But we don't have a special documentation for MLI. Yeah, for each picture, you can click download to download that special picture, or you can get the scoring pipeline for, this machine learning interpretability, like I showed you the reason code package. But we don't have a special documentation for that. Here, yes, the Shapley value. Yeah, you can download this picture, but we don't have a special documentation having these. Yeah.
It looks like you can download the Shapley values, which is not documentation, but it's a per feature observation value, so you can do your own interpretation of those.
Yeah. So this is the global Shapley value, and then when you select each individual, you will get actually. Let me just select. Go to the dashboard to select one individual here.
The reason codes down on the left at the bottom.
Left on bottom. This is the reason code for decision tree, but you also have the explanation here for coming from K-Lime.
Right, but you can download the reason codes and the Shapley value.
Yeah, you can download the reason code to get the Shapley. Shapley value is not exactly the reason code. They are separate.
It's pretty well described now. I've gone through the Google.
You mean the Shapley value, or?
Shapley value,
yeah.
It's well documented.
Yeah, Shapley value is definitely well documented, but I think the question here is about how can we link? Is your question how to link this reason code to Shapley value, or?
No, just that you have access to the Shapley values for every. It's not just the summary and global interpretation. You get back the matrix for all of your input data.
Well, let me see my. Oh, that's why it's dead. Let me just. Oh. Yeah, my instance, because I have 1 hour not used that instance, not running anything, it's shutting up. Let me just see, it's still running, or, wow, this is really slow. It's already 12 minutes, it's because I. See, yeah, the MLI package in this lab is still running for me. I probably need to restart my instance to show you, but the summary here is you can download the reason code, which is another scoring pipeline, very similar to our Python scoring pipeline. You can run that one on your new data to get the reason code. For each row, you will get the reason code. What's the contribution of each variable to your final prediction? Lots of people, especially the customers in financial services, like the banks, they're using that one to, make the decision, or at least to respond to business, people why we make that decision. For example, they have some home loan application. They reject certain applications, and then why we reject that application, you have to show them the reason code, because this person has bad value on these and that. That's the impact for the final decision. I mean, you can show them from there. Okay, is there any, other than the questions about H2O.ai or Driverless AI, is there any use case in your mind you think you want to discuss? Yes. Time series? Yeah, let me quickly just start my instance, and then I will show you time series. So overall, the time series we can handle here is a little bit different compared with traditional ARIMA model. We are using a machine learning way to build your time series model. So let me just, when it's starting, let me just quickly grab some, let me see if I have some presentation to show you, quickly show you. Or maybe just let's just go to our documentation here. Yeah. Time series, where's time series? Time series. This is a real example. Just expert settings, time series. I think it's just here. Let me. Time series. Yep. Okay. Let's quickly go here. Let me just see if my instance already started. No, it's still starting. Let me just go back to the time series here. So what we can do for our time series model, you need to give us your grouped data. Like for example, you are building time series model on your daily transaction data, daily sales. And then you have to give us your daily data. You can use different group by, like, we have an example here using the Walmart public dataset. For each store, for each department, they have a weekly sales. They want to predict what's the coming, like say 4 weeks or maybe 6 weeks, what's the sales for each store, each department. And then you have to pass us the data grouped by store and department with the date, with the weekly sales. After you pass us this, you also have to pass us what's your real production environment. Like, when we are building your time series model, in your production environment, generally people will not have yesterday's data. I mean, for example, right now it's January. Maybe they only have the data up to October last year, or maybe November last year, maybe September last year. You have to specify what's the gap between your data and the date you want to predict. Basically, that's it. After you specify these, after ask us to launch a time series analysis on our data, we will try to build a model and then give you the result. Others, they are the same thing. So you can apply your result on your new data or whatever the data you have to create your predictions. The gap means, for example, right now is March. It's almost April. Let's talk about April. I want to build a model to predict my April, May, and June, the monthly sales. But currently in my production, I only have data up to February available. I don't have the March data. I mean, I'm doing the prediction for the current time, the coming 3 months, but I don't have the last 1 month of data, or I don't have the data for the last 2 months. So that's the gap you have to tell us. We will use that gap to get a better prediction, because when we use this kind of gap, we cannot use the value for last month to build the model. We have to use maybe 2 months ago or 3 months ago to build it. I mean, when we generate features, we will consider these kind of gaps.
Usually your data actually grouped by store, for example, store and product, right? Does it build a separate model for each of those, or is it like somehow uses the entire thing to pull into it? Some stores may have.
So we have metadata, like for example, for each store, for each department, maybe you have other special things. Other than the sales, you have some other features, like maybe, I don't know, maybe the number of the employees, or maybe the size of the department, or maybe location, or maybe any feature related to that special store and department. You can list them as other columns. But we are building one model to capture everything here. We are not building millions of models inside of this data.
Like one store may have like very, very high sales, other store may have very, very low sales, while the other parameters could more or less be.
Yeah.
Because the reason is because that store is in New York City, the other one.
Yeah, that's depending on your store ID, right? You have a store ID, you have department ID, and then when you do the predictions, you provide us your store ID, and department ID. We'll capture that pattern.
So it basically comes up with a coefficient for store ID. Is that like, does it come with a coefficient for store ID?
It's not a coefficient, but similar thing. We will apply that one on that special store. I mean, we will look at that store, what's the historical data, and then use the feature there to generate the new sales. Yes.
If you go to global, let's say, global sales, you also can do
global sales, depending on which kind of sales you are talking about, for the whole store or Amazon?
All over the world, like.
And then you have to give us the data at Amazon level. I mean, not the single store in Amazon, but at Amazon level. So whatever you want to model, you just give us the data at that level. We don't do aggregation for you, but we do capture the time series, patterns there. Yeah. Okay. Any other questions? I mean, yes.
Is it independent models by store and department, or is it somehow groups, like a groups or other pools or other things? That's what I'm trying to understand. Is it like a...
Okay, let me just show you a quick demo. So my instance already started. Let me just go there and show you a quick demo about the time series feature we have. Okay, so the data set I'm using is a public data set for Walmart sales. Let's just have a quick look. They have store ID, they have department ID, they have date, they have weekly sales, they have some other variables like temperature, fuel price, markdown, CPI, unemployment rate, and sample weight. So for me, I want to build a model to predict what is the weekly sales. I just start from here, predict, and then I specify my target column is weekly sales. I'm pretty sure you guys like the correct that right. I don't have weekly sales here. Let me just go to dataset. This is the, okay, probably I click on testing. Let me use the training dataset, target column, weekly sales, and then I specify my time column is date. So that will bring me to an interface for time series models. So I need to specify, I want to group by store and department. That's the individual time series I want to consider. And then I need to specify how many weeks do you want to predict. For me, I mean, probably I want to predict like 2 months. I will specify 8. And then how many weeks do you want to start predict? This is the gap I'm talking about. So for your real production use case, when you want to start to predict, I mean, there may be a gap between the current time and also the latest available the data you have. Like you have 1 month ago, I mean the data from 1 month ago, maybe 2 months ago, that's the gap you need to specify here. If you don't have any gap, you can get the most recent data, like maybe yesterday's data. You can specify 0 here, and then just launch experiment. If you run, actually the algorithms behind this time series we will try to create lots of lags. Like, look at your last week's sales, 2 weeks ago, 3 weeks ago, up to like 100 weeks ago. I mean, we have some default value, which I believe is 100 or 200. We will create 100 or 200 lags and then figure out, and at the same time, this is only for the MA part, AR part, auto regression part. We also create something for the MA part, moving average. We try different combinations of the moving average, and then we try to figure out what's the features we will use for this time series model, and then we build a machine learning model to explain, to do the prediction. After this model is done, everything's very similar. We give you the scoring pipeline. You can also do the score here. Just input your new data, and then you get your predictions for the coming weeks or months.
So here if I see, right, you're saying target lag department store 8. So that model is for the store 8.
It's grouped by store ID department.
You mean this part here? Variable importance here. This, let's look at, so we have the store ID. So far store is pretty important, and date, day of year, get week is the week from the date. So those are the most important features right now. Let me see, what's this? Lag of target group by 8 time period. That's actually the sales 8 weeks ago. So the lag 8. Yeah. 20 is another one. Yeah, it's like the sales 20 weeks ago. No. Sorry. Yeah. I mean, that's the confusion. Yeah, I'm sorry. Yeah, definitely. I mean, if you just look at the detail of this variable, you will see what's the meaning of that.
And if you just use auto without 0 gap, just it will identify is there any gap or not based on current date.
If you do auto, if you want us to find the gap, you have to provide us both training and testing data set. So in that way, we will look at both to figure out if there's a gap. But for this one, I only provide training data set. I didn't provide testing. So that's why I specified 0 by myself. Yeah. Yeah, it will run a long time because time series definitely, we are trying more lags and moving average and autoregressive. So generally, time series model will take a longer time to run. But once running, any other questions? Yes.
Any plan to accommodate spatial data?
No, so far we don't have plan for that. Yeah.
And so you've shown that you can use it with AWS, and you said you can run it on a server. If you're in a more secure environment, is there a way to do that with an air-gapped server? Because presumably you're checking the license. Can you get it to?
Generally, what people are doing is, they will just put the license on that server, and then there's a parameter you can pass in the path of your license, and then they will automatically read the license from that location.
So but there's no need for anything to go back to you guys?
No, definitely not. Yeah.
And what is the privacy of this data? Let's say if I use my production data against your system.
The question is, what's the security of the data? So answer is depends on you, because this is only a software. You can install this one to anywhere, any environment. If you have your own lab in your company, you can just install there. Make sure that server only you have access. So it's not about us. You don't need to come up to us to run some modeling. So this is just a software. Right now, AWS is the host for this lab, but you can install that one to anywhere. What's that?
If it's an Azure cloud, it's up to Azure security.
Yeah, it depends on the contract between you and Azure, yes. Okay. So yeah, I think that's all I want to show today. And you know, just remember the best way to reach out to us is just H2O.ai, the website, and also just look at the documentation. And you know, we have different people here. You can reach out to us after this lab if you are interested to just, you know, move forward. Thanks for coming today. But yeah.